Dear students, welcome back. So today's video will be lecture on reactance diagram. So yesterday we have studied about pyramid system. So this is just an extension of pyramid system. So this is the question that given. You see a reactance diagram. Reactance diagram means you can say a single line diagram where we have to calculate the reactance of various components. Now see, this is a figure given. So this is a single line diagram of a power system. Here you have a generator, two transformers. The transformers are figured as T1 and T2. So this T2 I've written two times anyways. So T1 and T2, this is the transmission lines and these are the buses. Okay, these vertical lines are the buses. So this is a generator, the ratings and all these things are given. Okay, now you have to draw a reactance diagram by taking any base value. So to calculate the reactance diagram there are various methods. So case 1 we are dealing with. Now we will be dealing with case 1, later we will see case 2 and also we will see case 3. So different cases we will be taking. Now see here what rating is given. Generator rating, the generator is 30 MVA, 11 kV and the reactance is 1.6 ohm. So the reactances of all the components like the generator, the transformer, the transmission line, TL means transmission line, are given in ohm. You see generator reactance is 1.6, then transmission line 1, the transformer 1, this is T1, your reactance is 16 ohm per phase on high voltage side. Okay, so there are two sides, one is high voltage side and one is low voltage side. So on high voltage side it is 16 ohm per phase, and transformer 2 the reactance is 17 ohm per phase on low voltage side, and this is M means the motor, this is the motor. So motor, your power is given 25 MVA, 11 kV and reactance is 1.2 ohm. And transmission line, so transmission line reactance is 20.5 ohm per phase. Now what you have to do, you have to calculate the draw the reactance diagram by taking any base value. Now see, generally what we do for calculation of per unit value, what we do, we take the base value as the highest. That means in the figure whatever we may take as a base value, that means PU is what, actual by base. Now base equal to kV square by MVA. Now we always take the greater, that is the highest value in the figure as the base value. Now it has been asked in the question to draw a reactance diagram by taking any base value. That means any base value we can consider, but normally for easier of calculation we always consider the greater value as the base value. Now let us see in the figure, you see which is the greater value, 33 kV. In voltage it is 33 and the power is how much? The power is 30 MVA. So what we will consider, we will see that we will assume the base value to be 30, that is the highest power rating, and the voltage to be 11. Okay, 11 also you can take, 33 also you can take. Okay, the result would be same. Now let us solve the problem. Let 30 MVA and 11 kV be base at generating station. At generating station, let this be the base value. Okay, now see the reactance, all these reactance you have to calculate in terms of PU. So PU value I have already given. So see, ZPU equal to Z ohm into MVA by kV square. So this formula only every time we will be applying, that is Z per unit equal to Z ohm into MVA by this I have already derived, isn't it? So this formula only every time we will be using. Now see, first generator reactance, what is given, how much in ohm, but we'll calculate in per unit. This value will calculate in per unit. So that is reactance of generator in per unit. Okay, now see what is ohm value given, 1.6, that is Z ohm 1.6, and how much we have assumed as the base value, 30. So MVA is 30 and kV, it is connected to what, this generator, it is connected to 11, so 11 square. If you multiply, you will get 0.396 pu. So this is the reactance of the generator. Now reactance of the transformer. Now here you should be very careful while calculating the reactance of the transformer, because people make mistake here. So now see Z ohm, how much is the reactance of the transformer, how much it is given, 16 ohm per phase on high voltage side. Okay, so on high voltage side we have to take, this is transformer, this is low voltage side, and this is high voltage side, 11 kV, 33 is the high voltage side. We will be calculating, see this reactance is given on high voltage side, so we will be calculating on high voltage side, and base value is how much. Okay, now see how much is ohm given, 16, so 16 into MVA is how much, MVA is the base, that is 30. Now see kV, where we are calculating, we are calculating at high voltage side. At high voltage side, what is the voltage, 33, so we should take 33 square, 0.44 per unit. Okay, so students, you have to be very careful in this taking this value. Okay, this 33, this is very important. Next, xt2. okay, xt2. Next, xt2 in terms of per unit, what will get, you see transformer 2, how much is the value of transformer 2, reactance is given as 17 ohm, so 17 into what is the base value, is 30, and it is on what side, you see it is on low voltage side, so transformer 2 on low voltage side is how much, 11, so 11 square, so how much you will get, 4.21 per unit. Next comes the transmission line. So generator we have calculated, transformer 1 we have calculated, transformer 2 we have calculated. Next come the motor and transmission line. First let me calculate the TL, that is transmission line. Alright, let me take a new page. So TL, transmission line, reactance of transmission line in per unit. Okay, so what is the reactance given, 20.5 ohm, we have to calculate in per unit, so 20.5 into MVA is 30, and it is connected to what, let us say it is, this transmission connected to 33 and 33, so right here 33 equal to 0.56 4 per unit. What is left? Motor is left. So X motor per unit. How much is the value given? X equal to 1.2. So 1.2 into 30 divided by how much? Motor is connected to 11 kV. So 11 square 0.297 per unit. Okay, so these are the values we got. So we got the generator reactance 0.396, transformer reactance 0.44, transformer 1 and transformer 2 is 4.21, then transmission line 0.564, and for motor it is 0.297. Alright, now let us draw the figure of reactance. How to draw the reactance diagram? Now see how to draw. Generator will draw as it is, and this transformer will be represented by one reactance. This transmission line will be represented by one reactance. This transformer will be represented by one reactance, and this motor will remain as motor. Along with the motor, you have to connect one reactance. Okay, now let us draw. Let me take a fresh page. So our generator is there. Sorry. On generator EG is there. Now this generator will have some reactance. Now the transformer, then we have a transmission line, then we have another transformer, then we have a motor, so these are the things we have. So this is what actually generator reactance. This is transformer 1, this is transmission line, this is transformer 2, and this is for motor. Okay, so these are the things. Now let me write the values. What are the values we got? How much is Xg? 0.396, 0.396 per unit. Then transformer 0.44, 0.44, and then we have 4.21, 4.21, then we have 0.564, 0.564, and lastly we have 0.297, 0.297. Okay, so after every value you write PU, and here also PU. And one thing I haven't mentioned here, I have to throw the motor. Okay, here we have the motor. So this is the reactance diagram of this power system network. Hope you have understood. Okay, thank you.